Let's factor the polynomial completely. If the polynomial is prime, say so. Here we have the polynomial 81 x to the fourth minus 16 y to the fourth. There are two terms. There's a minus sign in the middle. We've got no greatest common factor to pull out. Let's see if it fits one of our special forms, maybe a difference of cubes or a difference of squares. As we inspect this first term, we notice that 9 times 9 will give that 81, and x squared times x squared will give that x to the fourth. So 81 x to the fourth comes from the quantity 9x squared squared. Our second term, inspecting it, we notice that the 16 comes from 4 squared, or 4 times 4. That y to the fourth comes from y squared times y squared. And so we can obtain 16y to the fourth by taking this quantity, 4y squared, and squaring it. So we see that we do indeed have a difference of squares, which fits the form. A squared minus b squared factors as a plus b, a minus b. In our polynomial, we'll use the value 9x squared in for a. We'll use the value 4y squared as b. And so this factors as a 9x squared plus 4y squared times the quantity 9x squared minus 4y squared. This is looking pretty good, but let's look at it closely. With our first factor, we have a sum of squares. Now, sum of squares does not factor, it is prime. But as we look at the second factor, again, we have a difference of squares. In it, that 9x squared comes from the quantity 3x squared. The 4y squared comes from the quantity 2y squared. So let's continue factoring it. Leave your sum of cubes alone. It does not factor. But our difference, that's a sum of squares alone. But our difference of squares does indeed factor as 3x minus 2y times 3x plus 2y. Sum of squares doesn't factor, difference of squares does. So our complete factorization of 81 x to the fourth minus 16y to the fourth is 9x squared plus 4y squared times 3x minus 2y times 3x plus 2y.